We're going to start with equilibrium, and the first thing I want to do is just talk about Kc expression and how to calculate it. So here's the first question. Write the Kc expression for the following equations, right? And please mind my shorthand, okay, because equilibrium is EQ and equation is EQN. So anyhow, so here are the three reactions given to us. So let's do the first one over here, which is calcium carbonate solid, and it is in equilibrium with calcium oxide solid and carbon dioxide, which is gas. So remember, in Kc expression, when you do this, you don't have to use solids or gases, so everything else is going to be in the expression. The other thing is that the products are on the top and reactants are at the bottom. Okay, so Kc is products over reactants, and then you raise it to the power of whatever the coefficient is, okay, in the balanced equation. So you have to work with balanced equations. Let's look at the next one here, which is Hg, mercury liquid, plus Hg2 plus in aqueous, and Hg2 2 plus. This is a polyatomic ion in aqueous. So yes, we can have equilibrium expression for aqueous substances also. And so in this case, our product is Hg2 2 plus. The coefficient is 1, so there's only 1 on the top there, and then the starting material is Hg2 plus, and again we will not have mercury liquid in here. The next one then is oxygen gas and hydrogen gas to give us water as in liquid, and so the Kc expression here is going to be products which we don't have any in gas state, so then 1 over and then oxygen and then hydrogen, but hydrogen is 2 coefficient, so we have to put 2 over here and square that. So those are Kc expressions. We write it very simply. Just don't try and complicate matters. Next question. Calculate the Kc for the following reaction at 74 degrees Celsius when the concentration of A, B, and C are 1.2 times 10 to the negative 2 molar, 0.054 molar and 0.14 molar respectively at equilibrium. So the equation is given to us, and remember, you do want the equation because it gives us the mole ratios, okay, and you need the balanced equation to calculate Kc. So then our Kc expression is C over A and the concentration of B. There are no coefficients over here, so we don't have to raise to any power. All we need to do then is plug in all the concentrations. Of course, concentrations. So 0.14 divided by 1.2 times 10 to the negative 2 for A, and for B it would be 0.054. And just do the calculation for this, and that is 216. And that's your answer for this one. So again, keep it simple. If the concentrations are given to you and you're asked to calculate Kc, just set up the Kc expression and do the calculation. And just don't forget the exponents. All right, third question. Determine the Kc for the reaction below with the concentrations given. So in this case, I kind of just shortened the question here, so I can save some space also. A plus 2B to give C plus D, and the concentrations are given to us for each of these. So which means all we have to do is set up for Kc, and the expression is going to be C and D over A and then B, but B is going to be squared. Now over here, if you can see that I've gotten a little lazy and I didn't really write the conditions, okay, or the states for A, B, C, D, and at this point we're just going to assume that they're all gases, okay, the same thing over here, okay, or all aqueous. Otherwise I will give you what the solids and liquids are, okay, but here I think I just kind of forgot, but anyway, now that I've remembered, I'm just telling you, okay, they're all gases, so which means you have to count for all. So 0.109 for C, 0.0110 for D, A is 0.0115 molar, and then B is 0.0253 molar, and then you're going to square that and you're going to use your beautiful calculator, and hopefully you will come up with the answer of 163 for this one. So keep it simple, write the Kc expression and then do the calculation properly.